So for this question 12b, they are giving us a situation. They say the ball is dropped from the height of 2 meters. Then each time the ball hit the floor, it will bounce vertically to the height that is 3 over 4 of its previous height. So let us illustrate this situation. Our ball we will drop from the height of 2 meters. So you're going to bounce. So you'll bounce and then again and then again continue. So for this bound, their height will be 3 over 4 of its previously. So the first one, find the height of the ball at the 10th bounce. So this is our first bound. We denoted it as T1. So second bound T2, third bound T3, and so on. They want us to find what is our 10 bounds here. So we have to count out a sequence first, where our first term here is 3 times 4, 3 over 4 times 2. And then second height of this, it will be 3 over 4 times the previous height, and so on. So our first term here is 3 over 2. That will be our A. And then we can notice that our common ratio here is 3 over 4 because they keep going to times a value 3 over 4, 3 over 4, 3 over 4. So this is an geometry sequence. So geometry series, geometry progression. So when they ask us to find what is the 10 bounds, what is the height of the 10 bounds, means T10. So for T10, formula is A R n minus 1. So where our A is 3 over 2, R is 3 over 4, and then n minus 1 will become 9. So this will give us the answer of, so that will be our height. So what is important here? The first one is how we apply our formula of A and R. So this is our concept, and this is our 10 bounds, the height of the 10 bounds. So for second questions, they are asked us to find the total distance traveled by the ball will until the 11 bounce here. So find the total distance that the ball will travel, the 11 bounce. So they will go up until 11 bounce. So how far they already how far of this ball already travel. So if we want to find the distance, you can see the first dropping here is 2. So the distance equals to 2, and then plus for each time of the bounce, it will be 2 to the 2 times of the height of the bouncing. So the first time height is T1, the second bounce height is T2, the third bounce height is T3. So their distance traveled, it will be 2 times because one going up, then one going down, drop. One is bounce up, one is drop, falling. And then one is bounce up, one is falling. So I have to plus 2T2 and then 2T3 and then adding until T11 to find out the total distance of this ball already traveled. So from here, we can see this is the concept of 2. When I factorize these two, it will equals to T1 plus T2 plus T3 plus until T11. So it will be the concept of sum to 11. So now we're going to find what is our sum up to 11. So sum up to 11 terms here in geometry progression, their formula will be Sn equals to A, since our r is smaller than 1, so it will be 1 minus r power n divided by 1 minus r. So we will plug in our first term here. This is the first bouncing distance here. Height is 3 over 2. And then 1 minus the r is 3 over 4. Power is n, so power is 11 divided by 1 minus 3 over 4. So we can calculate this in our calculator. So it will give us 13.493. So I will put 49. So that will be our total distance traveled. So what is important concept here? The first one, we must know how to calculate the distance traveled by the ball for every bounce here. Then we can meet up a concept where this is the sum to the 11 terms here. Then we're going to substitute our value where our A is 3 over 2 and the common ratio is 3 over 4. And applying the correct formula, we managed to get to our answer.